This is your stuff. I'm going to talk about this. This is your stuff. You're going to play on, for a time being, a nice hunter-gatherer group. Okay? We live in a nice part of the world. We've got lots of stuff available to us. We've got plenty of goods all the time. There's no shortages of anything. We're in good shape there.
I get all the rest, right?
No. There's no shortages. You need bananas. You have bananas. And I've also learned now that one chip does not stand the tray. You need bananas. You got bananas. For a lot of people in the world, if you have, we do math problems. Billy has 5 bananas. Nadine has 6 bananas. Billy gives Nadine his 5 bananas. How many bananas does Nadine have? 11. How many bananas does Billy have?
None.
No. There's bananas over there. I can go get bananas. Nadine has my 5, but I can go get more bananas. Okay? So you've got stuff. All right? You've got stuff. You've got 3 pieces of stuff. This is your worldly good. Right? This is fish. This is poi. This is breadfruit. This is bananas. This is coconuts. This is plantains. Crabs, oysters, all the good things that you want to have. You are on an even better island. You got lots more stuff. I want you to give all that stuff to other people. All right? Now don't give all of it to one person. You give one person a maximum of 10 pieces of stuff. But you can give people 1 piece of stuff. All right? You give people stuff. All right? Now give 2 more pieces of stuff because you're really generous. All right? But don't give it to people you've already given it to. You got to give it to different people. Right? You got to spread this around a little bit. And all the rest of you, if you want to give pieces of your stuff to other people, you can, as long as you have 1 piece of stuff left over. You can't give away all of your stuff. All right. But if you want to share your stuff with other people, you can. You've got stuff.
You're supposed to have one of these stuff.
You've got stuff. Now, this is the way it works in lots of places in the world. People are generous with each other. All right? I'm Storm. I'm Super Typhoon Randy. I just wiped out all your stuff. All right? Anybody who got a piece of stuff from her, give her a piece of stuff.
Read it down, don't you? Oh, no. Are you sure? I can handle it.
How many pieces of stuff do you have? 7 pieces of stuff. Did you have 0 pieces of stuff? When?
When you took them all away.
No. No. You didn't have 0 pieces of stuff. Your stuff was always out there. All right? Your stuff was always out there. Even though you got knocked out by a storm, your stuff was always out there. All right? In most cultures, reciprocity, this sharing, this is the norm. All right? This is basically, we got your back. All right? If you want bananas, you go get bananas. If a big storm comes through and wipes out everything you've got, the people you've given stuff before, they're going to give you stuff. They're going to give it back to you because, well, hey, I got stuff from you at some point in time. You've got something. All right? 0 is an abstract for these people. All right? The idea that you can have nothing doesn't fit within their cultural mindset. You can't have nothing. All right? It doesn't work. So 0 becomes an issue for these people. Then why did we invent 0? All right? Why does mankind invent it? Good question. All right? The Greeks hated it. Right? The Greeks hated it. And in the New World, they hated it. The Babylonians were going, there's no such thing. All right? We're counting things. The Greeks, no, we can measure stuff. All right? As long as we can measure figure area and volume, there's no such thing as nothing. Again, Archimedes, others, they argued against it. All right? You couldn't have 0. You couldn't have this kind of thing in there because the philosophy of it brings in some strange problems. So, we start at 0. There's a debate. From the Western world standpoint, from the New World standpoint, it's easy. The Maya had it. All right? And they probably got it from the Toltec and the Olmec, people who were there before them. And they certainly translated it on to all the other cultures. In the Western world, Ptolemy, 2nd century AD, he uses an O as a placeholder. All right? It kind of works in a little bit a 0. All right? But it doesn't quite work. Now, here's a real kicker to this. This rejection of the 0 that the Greeks insisted on, and the rejection of infinity, because 0 and infinity are twins. That rejection is the single thing that kept the Greeks from developing calculus. Had they embraced 0 and had they embraced infinity, they would have developed calculus long before it comes along later on in Western society. Right? The Maya had it, but still some issues that kind of go on with it. For the Western world, India. Okay? India gives us a lot of our concept for 0, a lot of the things that we need as we go through them. Okay? 500 AD, Arvada devised a number system that doesn't quite have 0, but it's positional. It kind of comes through there. He used the word ka to kind of relate where he was within this system. To let us know what's going on within it. I get off track all of a sudden. See, isn't this fun? Y'all get to be the first group to hear this, and I find out my slides just went wacky. No, that's okay. We'll find out where I am. We'll learn where I am, sir. Okay, so but basically, when we look at it, I mean, Ptolemy kind of gives us a little bit of an idea with it. All right, but a lot of our numbering system kind of does come from India. All right, this whole concept, and even within their religious writings, their concept of it, and the Upanishad, Changadra, the Upanishad, they believe where there is infinite, there is joy. There is no joy in the finite. All right, so the Indians started embracing this whole concept of 0, even within their god system. All right, by the time that the Greeks, with Alexander and others, come in, they're refining their god system. Instead of having many gods, yeah, you've got many names, but they're all kind of melding together. You have this concept of Nishala Shiva. All right, Shiva, the creator. Nishala Shiva is the creator without form. All right, they're embracing this whole concept of 0 coming into their culture, working with it to kind of bring it in to their system. Right? 0 is not a natural number. Right? Numbers refer to collections. All right? 1, 2, 3, 4 pieces of stuff. All right? How many pieces of stuff that you can have? The idea of a number becomes more and more abstract when we start talking about 0, because 0 doesn't add things to us. It makes it kind of weird. All right? And if we can kind of grasp this concept of 0, we get a little bit better on grasping this concept of the infinite. You're going to have 3 figures in India who are going to come forward as being important figures for the development of 0 as a concept as we start working with it. All right? They attempt to give us the rules for arithmetic dealing with 0. All right? Brahmagutra comes in first. He gives us these things that we all already know. As we go here, all right, addition, the sum of 0 and a negative number is negative, the sum of a positive number and 0 is positive, the sum of 0 and 0 is 0. All right, this is all simple stuff. Now, negative numbers becomes a big deal. You can't have that without 0. All right, you really don't have that concept. The Greeks didn't work, but you don't deal with negative area. All right, that didn't work for them. All right, for most cultures, it didn't work. You either have sheep or you don't. You didn't have negative sheep. Working with it. Subtraction, okay, that one gets a little bit trickier, and y'all dealt with some of this stuff working with it. Multiplication, actually fairly straightforward. Any number when multiplied by 0 is 0. All right. Division, okay. The Indian scholars spent 5 centuries trying to figure out how you divide it by 0. They spent a lot of work on it, and they kind of came up with things. And division with 0, they came up with, Brahmagutra and Aryabhata came up with, a positive or a negative number when divided by 0 is a fraction with a 0 as the denominator. 0 divided by a negative or a positive number is either 0 is expressed as a fraction with 0 as a numerator and the finite quantity as a denominator. 0 divided by 0 is 0. Okay? You got a headache yet? All right, it kind of works. It kind of works. All right? Well, that's what happens when you divide by 0. You know, there's any number of pictures about it. This actually is a picture of a house in Houston, Texas on Montrose Boulevard. It was done as a art project by 2 guys with the Art Car Foundation. The house was slated for demolition, and before they demolished it, they divided by 0. And here's what happens with it. It stood there for about a year. The house isn't there anymore, unfortunately. But that's kind of cool to get to drive by that. You know, I regret that I didn't get my picture taken in front of it when it was there. But I was going 40 miles an hour, and I couldn't stop because there had too much traffic around me to work with. All right, so the Indians, they had some issues with 0. All right. Bhaskara tries to write it, he tries to deal with it, you know, and kind of comes up with this thing, with problem solving by writing n over 0, he doesn't really have this correct. Quantity when divided by 0 becomes a fraction of the denominator, all that explanation. He still doesn't quite have it right. Dividing by 0 gives us some real issues. But the Indians worked with 0. They developed most of our concepts that we have of 0 and of infinity. All right? Because infinity and 0 are oftentimes the same thing. They're one and the same. They're twins with each other, working through it. Spread of Islam in 700. Islam changed the world in a number of ways. And one of the ways it changed the world was by introducing forms of mathematics that hadn't been introduced to the rest of the Western world at that time. They picked up what was going on in India and in China, but primarily in India, and brought it in there. Al-Khwarizmi becomes an important character within the math world. He writes his first treatise on mathematics. It's called Al-Jabr, and from that we get the word algebra. He was also the first one to describe the concept of algorithms, this concept of these tricks for multiplication and division. Algorithm itself, the word algorithm, is a bastardization of Al-Khwarizmi's name. That we get algorithm from his name out of this. Al-Khwarizmi is important to us also outside the field of mathematics. We're beginning to look at his writings in medicine. He writes in the 8th century, 9th century. He writes of diseases that come about, as he calls it, from abuses of nature. In other words, people getting jiggy when they shouldn't, with people they shouldn't be getting jiggy with. But his descriptions, one of the descriptions he gives of that is a dead-on ringer for Kaposi sarcoma. He is basically identifying and describing HIV/AIDS as early as the 9th century AD. So he becomes a very important figure working within the mathematical world. Fibonacci, who gives us the great sequences, he did the whole thing, that we had a generation of rabbits, and you had a male and a female, you let them breed. How long before they got a generation? Well, you had one generation, and then they had a generation. All right, well then, those generations, get together. Well, that first generation is still a little bit young, but then, all right, finally you get 2 generations of rabbits. Well, there's one in there, and so you get 3, and then you get 5, and then you get 8. There's always this lag time behind here. Now, you take the Fibonacci sequence, you've got that 1, 1, 2, 3, 5, 8. 8/5 is 1.6 repeating numbers. 13/8 is 1.6 repeating numbers. That golden ratio that Pythagoras developed, that Pythagoras brought into us, comes showing back up within these things. 0 is a useful construct. Fibonacci didn't even really work with 0. He knew about it. He studied math in the Islamic world. He went to the Middle East and studied mathematics. He was deemed a very good student, but he didn't really quite work with 0 very often. Cardan solved cubic and quadratic equations without using 0. All right, kind of a strange concept, but he was able to do it. It's really not until the 1600s that 0 comes into play in the Western world. Bernoulli is the first one to really use it, and by using 0, we can do points. All right, this whole concept that most of you have ever done an art picture, being able to draw something and have that vanishing point in a picture, perspective. That point is 0. It's also infinity. Look at paintings prior to the 1600s, to the Renaissance. You get very flat, one-dimensional paintings. Everything is out of whack because artists and scientists and others, they didn't accept 0. They didn't use it. Bernoulli does, and he does the first paintings, the first drawings that give us 3 dimensions, that give us scale, that give us a vanishing point that works with these things. But still, 0 is kind of problematic. Right? It's still, they're not really worth, they really don't like it too much. The problem is 0 violates everything. All right? It doesn't increase, it doesn't decrease. It violates the distributed property of things. All right? It doesn't add anything. You can't add 0. All right? You really can't do much with it. It doesn't multiply, and division causes a whole lot of problems. But we accept 0 in our cultures today. Right? We understand it. And it still sometimes gives us a little bit of an issue, but we work with it more. We start off at 0-100 hours. If you get the military clock, you start off at 0-100 hours. We talk about ground 0, not ground 1. All right? We talk about zeroing in on things. All right? We work with it as a process, as a concept, as a prospect. So, now you get to take notes. All right? There's some math problems. If it's in blue, write it down. All right? We're going to walk through this. And this is really This is 0 in its nastiest form.